Hi everyone, so this is the last video in the lesson, and it's all about two-column proofs. So two-column proofs are just one kind of proof, and this is one of the easier proofs to talk about because in a two-column proof, it asks you to do something like solve an equation or prove that something is equal to something else, and the way you do it is you actually solve the equation or you go through the process of proving it, but then in one column, and then in the second column you tell me the reason why that works. So you have a statement column and then you have a reason column, and we'll do a couple of examples in this video, but for now, for these two-column proofs in this video, we're going to talk about algebraic proofs, which basically means we're going to solve an equation and then prove why it makes sense. And to do that, we need to know some properties so that we can give reasons why. So here are a couple of properties, algebraic properties of equality. They're not all of them, but these are the ones that we'll be using in this video. So you have a cheat sheet with all of these on there. I just wanted to go over them really fast in this video. So the first one is the addition property of equality, which says that if A is equal to B, then A plus C is equal to B plus C, which basically says that I can add the same thing to each side of the equation, and the equal sign still says each side is still equal to each other. And then the subtraction property of equality is really similar. It says if A is equal to B, then A minus C is equal to B minus C, which tells me that I can subtract the same thing from each side of the equal sign and it still holds true. Then we have the multiplication property of equality, which says that if A is equal to B, then A times C is equal to B times C. I can multiply both sides by the same number and the equality is the same. Then the next one is the division property of equality, which says that if A is equal to B and C is not equal to 0, then A divided by C is equal to B divided by C. That one has an extra little chunk on it where it says that C can't be equal to 0. The reason why that is because we can't divide by 0 or else it doesn't work, and so we have to have that extra part in there. Then we come into a couple of different properties, and the first one we're going to talk about is the reflexive property, which says that A is equal to A, or you could say B is equal to B or C is equal to C. It just says that the same thing is equal to the same thing. Most of the time we don't necessarily think about the reflexive property because we already assume that it's true, but there is a name for it. It's called the reflexive property. The next one is called the symmetric property, which says that if A is equal to B, then B is equal to A, which just says that I can flip-flop where they are. They can be on the left side of the equal sign or the right side of the equal sign, and it would still be the same. Then we have the transitive property of equality, which says that if A is equal to B and B is equal to C, then A is equal to C. And that one's really similar to the next one, which is the substitution property. The substitution property says that if A is equal to B, then A may be replaced by B in any equation. So on this one, you can just replace the A with B in anything, whereas the transitive property, it's more linear. It says if 1 is equal to 2 and 2 is equal to 3, then 1 is equal to 3. Like we can bypass the second step. And then the last property that we're going to talk about is the distributive property, which says that if I have A times B plus C, then that's equal to A times B plus A times C. We've already talked about the distributive property in this course. It just says that if I multiply something inside parentheses, I multiply both chunks of what's inside the parentheses by whatever's on the outside. Okay, so those are the properties that we're going to be talking about. And in the first two examples, instead of doing a proof, we'll get to those later, but instead of doing a proof, we're going to just state which property makes the most sense, or why the statement works. So the first example says if A plus B is equal to C and C is equal to D plus E, then A plus B is equal to D plus E. So this looks a little bit different than what we were looking at before, but do you see how it goes like A plus B goes to C and then C goes to D plus E? So we can kind of bypass that second step and just go from A to B, A plus B to D to E. And that is called the transitive property. So that's my answer here. It's the transitive property. All right. Now the second example says if 10x is equal to 30, then x is equal to 3. On this one, the way that I like to think about it is, how would I solve this? So to solve it, what I would do is I'd actually divide each side by 10, right? Because I want to get the x by itself. Well, if I divide each side by 10, I end up with x is equal to 3, which is great. But in order to do that, I needed to use the division property because I divided both sides. So the property that I used here is the division property. Okay, so the first couple of questions on your self-check are like this. You just need to determine what property is used. Then the last couple of questions talk about proofs. So let's go through a couple of examples there. The first one is, given that we have 6x minus 4 is equal to 3x plus 8, we need to prove that x is equal to 4. So on here, I've filled out a couple of portions, and what we need to do is fill out the rest. So the first, as we kind of talked about, you have a statement column and then you have a reason column. So some of the times the statement's filled out, some of the times the reasons are filled out, but we just need to fill in the rest of the boxes. So the first statement that we have is 6x minus 4 is equal to 3x plus 8. And that is actually what was given to us. So my reason that I have that is because it was given to us. Given can be a reason. And that is always your first reason, because when we do two-column proofs, you always start with what was given to you. Then the next line on the statement column says 6x minus 4 minus 3x is equal to 3x plus 8 minus 3x. Now this looks a little bit different than what we're normally used to, because we're used to seeing them like written, like when we subtract something or add something or multiply by something, we're usually writing it below the equation. But in this case, notice that you subtracted 3x from each side, but it's just kind of like written in line with it. That's totally fine, because it doesn't really matter the way we write it, but we need to figure out what the reason is for it. We subtracted 3x from each side, which means that this would be the subtraction property. Okay, then the next statement in the statement column is 3x minus 4 is equal to 8. And if you notice, this one is just if I were to combine like terms or simplify. And so simplify is my reason, which again, even though that's not a part of the algebraic properties that we were just talking about, we can use that as a reason. We can just simplify. Okay, now we have the next reason, which is the addition property, but we need to fill out the statement portion. So we have this equation, 3x minus 4 is equal to 8. We want to solve that for x. So to solve that for x, what I would normally do is add 4 to each side to get the x by itself. So I can write this out as 3x minus 4, but I'm going to add 4, and then is equal to 8 plus 4. Because what I do to one side, I have to do to the other side, right? Well, I did what this reason said, because the reason is addition property, and what I did is added 4 to both sides. Then the next statement, or the next reason, says that I simplify, so I'm just going to simplify that by adding the 4's on each side. So on the left side, the negative 4 and positive 4 cancel each other out, and I'm just left with 3x. And then on the right side, we have 8 plus 4, which gives us 12. Okay, then we have the next statement, which is 3x divided by 3 is equal to 12 divided by 3. Notice that we had to divide both sides by 3. So this would be the division property. And then the last one, both of them are blank. And so what I'm going to do is actually divide by 3. The 3's cancel out on the left side. I'm just left with x. And then 12 divided by 3 gives me 4. And that's what I wanted. Okay, so x is equal to 4. That's what I wanted to prove. How did I do that? What was my last reason? It's because I just simplified. I actually divided, and so I simplified the answer. And that is a two-column proof. Okay, let's do the last example. So the last example says that given 11 is equal to 3 times x minus 4 plus 2, we need to prove that x is equal to 7. So the first statement is blank, but the reason is given. When we have something that's given, it's just what was given at the top. So my first statement would be 11 is equal to 3 times x minus 4 plus 2. Then the next statement is 11 is equal to 3x minus 12 plus 2. Notice the parentheses went away. The only property where parentheses go away is the distributive property. Okay, then The next steps, or the next reason says simplify. So I think that I'm going to simplify here by combining like terms, which are the negative 12 and 2. So I'd have 11 is equal to 3x minus 10. Then the next statement is given where it says 11 plus 10 is equal to 3x minus 10 plus 10. So notice that we added 10 on each side, which must mean that we use the addition property. Then the next reason is simplify. So looks like we just have to combine like terms again, which would give us 21 is equal to 3x. And then the next reason is the division property. So I'm going to divide. So I'm going to do 21 divided by 3 is equal to 3x divided by 3, which is the division property. It's kind of not lining up right there. And then the last section is blank, which means we're going to assume that we just simplify and actually divide. And when we actually divide, I get 7 is equal to x, which is exactly what we wanted to prove. So 7 is equal to x. We are all done. And this is how we deal with two-column proofs.